Hey guys, for a bit of fun, I thought I would talk about some dimensions of the flat Earth versus the spherical Earth. Let me know if I've got this right, particularly for the flat Earth. I'm just going by what I think flat earthers say are their dimensions, although I suspect there could be some differences of opinion amongst flat earthers. So, first of all, we've got the globe, which I have no problem believing in and accepting following at least 2,000 years of science, if not more. And here would be the flat Earth with the North Pole in the centre, the ice wall around the edge, and no concept of south. There's no South Pole. South is purely in relation to where you're standing on the North Pole, I guess. So let's start with the meridian. The meridian is the line that goes down the sphere from the north to the South Pole. On the spherical Earth, that would be 20,000 kilometers in length, or 12,429 miles. From the North Pole to the equator would be half that distance, 10,000 kilometers, or 6,213 miles. So here's the meridian on the flat Earth. The North Pole to the ice wall would be the radius, 19,714 kilometers, or 12,250 miles. And the North Pole to the equator would be half of that, I assume, 9,857 kilometers, or 6,125 miles. The spherical Earth, the radius is from the core of the Earth to the outside of the sphere. That's 6,371 kilometers, 3,958 miles. The diameter of the flat Earth would be double the radius, 40,233 kilometers, or 24,500 miles. On a spherical Earth, the diameter is 12,756 kilometers, or 7,926 miles. To travel from the North to the South Pole on the flat Earth, 19,714 kilometers, or 12,250 miles, which is equal to the radius on the flat Earth. On the spherical Earth, it's roughly 20,000 kilometers, 19,955 kilometers, or 12,400 miles. That is the meridian and roughly equal to the flat Earth radius. Travel from the North Pole to the equator, flat Earth, 9,857 kilometers, 6,125 miles. Spherical Earth, 10,000 kilometers roughly, 6,220 miles. Now I have a problem here for the flat Earth, and that is Coriolis force. Let's go back. So at the equator on a spherical Earth, or at the equator even on the imaginary flat Earth, there are no hurricanes, or extremely rare, because the Coriolis force is zero. That's pretty easy to explain in spherical Earth terms. I would be interested in understanding how that phenomenon would occur as explained by a flat earther. The South Pole, some problems, does not exist on the flat Earth. Instead, it is a ring of ice around the circumference of the flat Earth. Therefore, South does not really exist on a flat Earth. Now, remember, magnets must have a north and south. So when we're talking about the Earth's magnetic force, that poses a bit of a problem for flat Earth. So then circumference of the Earth, that would be calculated as 2 pi r, or diameter times pi, pi being 3.14 approximately. On the flat Earth, the circumference is 123,806 kilometers, or 76,930 miles. Have I got this right? I'm basing this on the radius of 12,250 times 2 times pi. On the spherical Earth, the circumference is 40,075 kilometers, or 24,901 miles. Distance around Antarctica. So up until this point, the flat earthers can kind of use their dimensions to kind of sort of match spherical dimensions, sort of. But here's where the big problem comes. So here's the challenge: get a yacht, go to the ice wall, and sail around it. So put a flag in the ice wall. If you can evade the NASA penguins with machine guns, jump on the ice wall, put a flag in there, go all the way around, and measure the distance. It should be 123,806 kilometers, or 76,930 miles on the flat Earth. And my understanding is that it's 22,000 kilometers on the spherical Earth to circumnavigate Antarctica, or 13,670 miles. The coastline is 11,165 miles on spherical Earth. Here's the challenge then. Google the Antarctica Cup yacht race, because this is a real thing that actually happens. I've cut off some of my... I'm just using PowerPoint here, to be honest. Let's get back to this slide then. Challenge. Look at the ice wall from several points on Earth with a telescope on the flat Earth. And people are saying, well, you can't look at a telescope on a flat Earth because the atmosphere interferes. Well, the fact that why don't you Google observing planets and stars with a telescope during daylight hours then, in that case, see what you find. But look at the ice wall from Madagascar, Ushuaia, New Zealand, Australia. Hell, why not just look at it from Alaska? What the hell? On a flat Earth, you should be able to see the ice wall from any direction, really. Yet to see any evidence of that. Measure the distance. That's it, folks. Ciao for now.